Well, over the weekend, there was a disastrous hurricane, super typhoon, in fact, just off the uh, east coast of the Philippine island nation. And I think one person has died in the Philippines, probably a person at sea, although I don't know the details. Uh, Remarkable, lucky situation there because this was one of the strongest typhoons in the West Pacific in history. The central pressure dropped to 888 millibars, nearly an all-time record, and the wind speeds on Sunday afternoon local time were 190 mile per hour sustained in the middle of the storm, and that was Sunday was of course the 18th. So I want to show you some satellite movies of Super Typhoon Suragai, and you can see it. We've been talking about hurricanes. They're warm core disturbances in the middle of the cyclone, and that means that the thickness gets larger and larger and larger with increasing elevation. And so at the top of these storms, there's actually an anticyclone at the tropopause. You can't really see in this particular event evidence of the clouds rotating clockwise around the center of it. That's partly because it's at such low latitude, and it's also because the storm is obscured by such deep convective towers. But watch when this goes. I'm going to start showing you a series of images here on this screen. It's sort of a blowout. You can see the Marianas to the east, Guam, the Philippine Sea is in the center, and then Taiwan and the southeast coast of China. Then there's Southeast Asia, Vietnam, Cambodia, Laos, and Philippines are in between there. And there is the beginning. We saw this a little bit on Friday. I gave you a close-up image of Suragai at this point in the storm's history. Now I'm just going to go paging through and watch how the eye of the storm will start to show up out of this gloom in the middle. This is every hour now. So you can see the storm. There's the eye sort of emerging for the first time on midday Friday. There's a really clear picture of the eye of the storm. And then we go to a visible satellite image where it looks slightly more obscured because in the prior ones we were looking at infrared. And notice the storm is still fairly compact. Here's maybe the front edge of the outflow of the hurricane. Here's the main storm itself, but the outflow is way out ahead of it and further to the north. There's Taiwan. It's encroaching upon the southern part of Taiwan. And you can see all of the cloud elements kind of streaming in towards this storm. It's really an incredible beast of a storm. The eye looks really good even at almost noontime for the satellite. And then we go into Saturday morning and look at the eye of the storm at this time. Just unbelievable, isn't it? And watch, I'll overlay what sort of intensity we were at this time. And at that time, we were in hurricane, super typhoon intensity right around this time. And I'll take that off again because it obscures the eye. And then we'll animate just around this time. So you can see how that thing is rotating beautifully counterclockwise. And dense overcast. There's not a single spot in that overcast around the eye that's penetrating or that has a hole. But look at these thunderstorms that pop up on the far periphery. All of these spiral rain bands are all thunderstorms. And the winds are here and howling at about 140 by this time. It gets worse. So I'm going to move forward a few more clicks. This is now into Sunday, and you're going to see the hurricane. Look at the wobble in the eye. That's one of the characteristics of these things as they rapidly intensify. This thing went crazy overnight, Saturday into Sunday, with the hurricane intensity, the winds going up to 190 mile per hour. And this is a Category 5 hurricane, the first one on Earth this year, and way ahead of schedule. And so here's Manila, here's Sorsogon City in the Philippines. The eastern cities are the ones that are the most prone to hurricane attack as the season goes on. And Suragai kicked up extraordinary winds in the center of the storm and then huge waves out to its east. So an absolutely beautiful example of a tropical cyclone. And currently, keep on clicking forward, you can see the eye gets obscured here and there. This is now a next visible satellite image during the day yesterday. And it doesn't look like there's much of an eye. We'll see when we get back to the nighttime. The eye has gone away overnight. And we'll animate a little bit here and see what this looks like. But the storm is still very intense and more or less sitting still for much of that period of time over the last, 12 or so hours. So this is a near disaster in the Philippines, an incredibly intense storm, and one that is certainly worthy of attention. So if you've got some time and some interest, go ahead and look for some other resources on this thing. But an absolutely beautiful event that occurred just over the last few days. So current weather over us is changing. We've got a cold front coming through the state with a little bit of rain associated with it this morning. The cyclone is over eastern Lake Superior. And back in the cold air behind the cold front, there's light snow all the way from far western Montana into central Iowa. It's not impossible that we won't see a snowflake here or there the next day or two, but I suspect we're going to be just warm enough to avoid that. But not every place in the state will be so lucky. So it's going to be chilly over the next couple of days. Incidentally, this is the third year anniversary of a 7-inch snowfall we had on the 19th of April in 2018. So that was pretty unbelievable. So it can still happen, and it is happening in some places not far away from us. Then there's another cyclone that's off the coast of the Canadian Maritimes, and trailing south of it is a cold front. It's not analyzed here, but you'll see evidence of it in some of the other maps I'll show today. Cold front that's trailing southward, and then there's another weak disturbance off the North Carolina coast, and the cold front continues across the Gulf of Mexico as analyzed on this map. But there's really a temperature contrast zone all the way along the east coast that we'll see reflected in the position of the upper level wind speed maxima. This one to a lesser extent because the air is rather shallow in this case. This is a deeper cold air mass. And then there's an anticyclone building on the border of Saskatchewan and British Columbia right now that'll pull in some cold air for us over the next day or two. So here's the temperatures that as we see them right now at 7 o'clock Central Time. 39 in Madison, 38 Green Bay, 34 in Marquette, 29 in Duluth. Is it ever spring in Duluth? I think 4th of July maybe. 26 at International Falls. And very warm over South Florida. Look at that, 78 at Miami, 50 in Atlanta. So here's that strong temperature contrast region that I was just talking about with respect to the surface map. 63 at Cape Hatteras, only 38 at Huntington, West Virginia. So these are really substantial horizontal temperature contrasts. And now we know what that means. If you've got a horizontal temperature contrast, you're going to have an increase in the westerly winds with increasing elevation. And there's no way around that because the thickness in the warm air is deeper from 1,000 to 500 millibars or 1,000 to 300 than it is in the cold air out to the west. Consequently, the upper level isobars have a tilt to them, a slope, which forces there to be a larger and larger pressure gradient force the higher up one goes in the column of air. And so the wind speed, geostrophic wind speed, keeps on getting larger, and that's what we call the thermal wind just the other day. So there's a nice picture of the temperature contrast along the southern states. Notice the contrast here is not as great across the western plains. You know, you're at 31 degrees in southern South Dakota and only in the mid 30s to 40 in Colorado. So there's not really such a sizable temperature contrast in this location of the country as there is on the southeast coast. Okay. But notice temperatures are around 20 degrees in central South Dakota, North Dakota. So the air is chilly back here behind this cold front that's just made its way through. Look at this interesting observation. Chicago at 7 a.m. was 50 degrees. Madison was 39. That's 11 degrees temperature difference over and 10 between places on the eastern shore of Lake Michigan and Green Bay. That's the cold front right in there, that temperature contrast. And that will come associated with a dew point contrast almost always, and it does in this case. We've got really much drier air to the west of Madison, temperature dew points in the teens, and we're still 34, hanging on to a little bit of moisture. I bet you even now as we're talking, that's dropped into the 20s, low 20s. And then the only place where there's really high dew points is the Florida Peninsula, 60 at Jacksonville all the way to 73 at Miami. That's downright tropical, same as at Tampa at 58 or 68. So pretty soupy air across Florida, moderately so in the southeast, and very dry and cold up near where we are. So here is the satellite movie over the continental 48 and adjacent waters. So here's the cyclone off of the Maritimes, and you can see it's spinning obviously counterclockwise right there in the south of Newfoundland. And then here's the cloud mass associated with it, and that is along which there's a substantial temperature contrast, this cold front that's especially intense, as we just saw on the surface temperatures, down over the southeast states and the southern Gulf states. Okay, so we'll see that. Here's the cloudiness associated with and the cyclone center of circulation just over eastern Lake Superior associated with the feature that's going by us. So we just had the clouds come through with a little bit of drizzle this morning. The clouds will likely stream across us much of the day, keeping the threat of rain alive, but not very heavy rain. And yet it back behind here is really cold air, and that'll funnel in during the day today. So temperature won't rise much today. It's about 40 right now, but I don't expect it to go up. I expect we're going to be having a battle between cold air advection and the daytime warming that may or may not occur because of the cloud cover. And so we may well see that the advection wins out and the temperature drops. We'll wait and see. It'll be kind of an interesting battle. Then let's take a look at the radar to see where these clouds are actually precipitating. And that's right here. Let me set it up. So you can see beautiful thin line of cold frontal type precipitation that went through Madison this morning. I noticed on my windshield when I went out to get the newspaper today, there was water on it. So it had rained a little, but it's not now. And then this is all snow back in Nebraska, into Iowa, and Wyoming, and parts of Montana, as I mentioned before. So that's all snow along the cold front. And you can see it's a little bit higher reflectivity, yellows, reds, and oranges here in Michigan, where it's warm enough to rain. But when it gets cold enough to snow, those go away. You don't see as much. Here's the convective activity over the peninsula of Florida. So it's warm, moist, and right ahead of a cold front. And so there's some pretty decent convective showers blossoming across the state and on both coasts, as you see. And then a little bit of precipitation in the western middle Atlantic states. Nothing too much to report anywhere else across the country. So a fairly nice day across the United States today. So before we go to the West Coast satellite image to finish up, I just want to show you a couple of images that I've saved from today's weather map. Even though it's dated incorrectly, I'm not sure how that happened. This date is wrong. This is from this morning at 12Z. See? So this is the 850 millibar map from this morning. Sorry about that date being wrong. And here we are in Madison. And here's the 850 millibar isotherms. They're not colored in, but the red lines are lines of constant temperature. And notice Minneapolis is 0. And it's colder than that in many places to the south. Warmer than that in many places to the south and east. And here's a strong temperature contrast in this exact region that we're seeing. And so if I put the frontal analyses and the cyclones on this map from the surface map, you can see here's the cold front along the east coast that we just saw some evidence for in the temperatures and also in the precipitation across the state of Florida. And here's the cold front that's draped across us. This is some hours old, so it hasn't quite gone through by the time this map was drawn. And so this is just a little bit behind the time. And then if we go to 500 millibars, I put the same surface analyses on top of that map, and you can see some relationships that are quite dramatic, and we see them routinely, as I've said many times. First, here's the surface cold front. The leading edge of the cold air that's invading across the southern states is on this blue line. At 500 millibars, it's quite a bit further back to the north and west, because there's a strong temperature contrast indicated by the close spacing of these red isotherms across Virginia, the Carolinas, Mississippi, Alabama, Louisiana. That's where the strong temperature contrast is. There isn't as strong a temperature contrast at 500 millibars here as there was at 850. Stronger temperature gradient at the ground than aloft. This is it. It's about 5 or 10 degrees. That's it, right in that location across North Dakota, parts of Montana. Okay, cyclone is downstream of an upper trough. I'll go back to see. Here's the troughiness in the flow. The black lines are the equivalent of isobars at 3 miles above the ground. So there's your trough. And then here's a big ridge over the western United States, Alaska, and the ocean to the north of Alaska and the Canadian archipelago. Down sheer of that, so down to the east of the big anticyclone aloft, the big ridge, there'll be a high. And that's where we saw our high pressure building at the surface over the border of British Columbia and Alberta. And then downstream of the trough, there's a cyclone. And we saw that clearly in the satellite as well as in the surface map, cyclone over eastern Lake Superior. So again, and I could point it out for the other features, but I've decided not to in the interest of time. Again, these relationships are absolutely robust. You can bet your house on them. Okay, they're always going to work this way. Now, the most recent thing we've been talking about is what is the impact of a horizontal temperature contrast that exists throughout the depth of the atmosphere. So we've got a cold temperature contrast here. It's colder to the north over southern Missouri than it is over Florida at 500 millibars. It's also, obviously, we saw on the surface map, colder in Missouri than it is over South Florida. So we have a deep tropospheric temperature contrast. In the cold air over Missouri, the thicknesses from 1,000 to, say, 300 millibars are quite small because it's relatively cold air. The thicknesses from 1,000 to 300 millibars over Miami are quite high. And so you've got a very high 300 millibar pressure surface over Miami and a quite lower one over the boot heel of Missouri. That means it slopes downward, and the geostrophic wind will keep getting stronger from the southwest over that region of temperature contrast, which occupies the southern states. And look at this. Here's the 300 millibar map. Son of a gun, there's the jet stream. These colored contours here are isotax, lines of constant wind speed. When you get into these white within the purple, you're over 130 knots of wind speed. And so the purple is 110, the first white is 90, and the outside gray is 70. So this is a really strong upper tropospheric jet stream, and it's sitting right over the region where we saw the strong temperature contrast, both at 500 millibars and at 850 with the cold front. Okay, so very nice, isn't it? How this relationship, a new one we've been talking about, is perfectly aligned with what we expect. Strong temperature contrast across the southeastern United States in the horizontal means a increasing wind from the west and southwest manifesting as a jet stream at 300 millibars, about 6 miles above the ground, off the east coast. And that is dramatic. Remember, we had a little bit of a temperature contrast at 500 millibars over Montana, North Dakota, and parts of Saskatchewan and Alberta. Right in here, these two red isotherms, just upstream of the trough. Well, there's a little bit of a wind speed maxima in that location, and that's 70 or in some places 90 knots. There's a little weak, much weaker jet stream than this one. This one we actually call the subtropical jet stream because it gets down that far south. This one's more of a polar jet stream. And there it is. You can see these relationships are really manifest and really obvious when you look at daily weather maps. So I encourage you to do that if you have the interest. You'll find that it's worth your time. Finally, let's take a look at the West Coast satellite image, and you can see a really beautiful counterclockwise spinning cyclone in the Gulf of Alaska here that's getting gradually deformed as the movie goes on. But there it is, quite a nice looking storm. Here comes some clouds west of the state of Hawaii, which is right here. And you can see them emanating from the tropics, getting themselves perhaps even incorporated into this circulation in the Gulf of Alaska. Then a new disturbance at upper levels starts to show up right in there, and that's got a counterclockwise rotation to it. And that will also be the beneficiary and exporter of these clouds that are coming in from the tropics. And then on the far periphery of the image, you can see a cloud plume that goes out up towards Kamchatka Peninsula, and that is outflow from Surugai. So that's getting carried poleward by the jet in the far western Pacific. So a lot of interesting things going on today. And I hope that you're enjoying this manifestation of all the things we're learning in class show up on real weather maps. That's why I got excited about Section 4 in the course, because it integrates a whole bunch of different things that we've talked about all the way through the term.